Greetings to one and all. I am Raghav, a final year undergraduate student from Indian Institute of Technology, Kharagpur, and today we are here to look at our work and evaluation framework for legal document summarization. The authors are Ankan Mullick, Abhilash Nandy, Manav Nitin Kapadnis, Sohan Patnaik, R. Raghav, and Roshni. So, if we look at the case of a law practitioner, in his day-to-day life, he has to go through numerous lengthy case proceedings for their practices in various categories such as land dispute, corruption, robbery, etc. Hence, it is a necessity to summarize these documents and ensure that these summaries contain the phrases with intents matching the category of the case. So the motivation for our work is that to the best of our knowledge, there exists no evaluation metric that evaluates a summary based on its intents. So we propose an automated intent-based summarization metric which shows better agreement with human evaluation as compared to other automated metrics like view, rouge, L, word-word similarities, etc. We also curated a dataset by annotating intent phrases in two different sets of legal documents, Indian and Australian legal documents. We also show a proof of concept as to how this system can be automated with the help of a demo website, which is live right now. So, if we describe a dataset, we scrape around 5,000 legal documents from common LII website using Selenium Python package. Out of them, 101 documents from the categories of corruption, land dispute, murder, and robbery are randomly sampled, and we mark this as the Indian dataset. For the Australian dataset, we downloaded the legal case reports from the UCI ML repository and annotated 59 relevant documents. So, right now we have Indian dataset and Australian dataset in hand. In the data annotation part, there are two steps. We did the initial filtering, where two annotators filter out sentences that convey an intent matching the category of the document at hand. For example, if the document is of the category murder, then annotators filter out sentences that convey that, okay, this is a sentence which could be related to murder. Once this is done, then the intent phrase annotation was done where two other annotators extract a span from each sentence so as to exclude irrelevant details like the name of the person, the date of the incident, the place of the incident, etc. And only include those words which exclusively correspond to the intent in hand. So the resulting spans are called the intent phrases. And if you look at the Cohen coefficient K, the overall inter-annotator agreement is 0.79. And the table below summarizes our data set in terms of number of documents, the average words and the average number of sentences, and the average number of intents, average number of words per intent phrase. So now we will look at how we have defined our metric. So there are actually two types of summarizations. Summarization could be extractive, where the summary has spans from the original text, or the summarization could be extractive, where the summary is generated using the original text. So we introduce an intent-based F1 score and human score metric, which is related to Spearman triangle correlation for the evaluation of a summary, and we refer to it as the intent metric here on. We propose an automated intent-based summarization metric for extractive summarization. So we report the average intent-based F1 score over all the documents. So to understand our metric, it is important to understand. So we have defined what is called as a closed pair. A closed pair is a pair of intent phrase and a sentence from the summary such that the intent phrase is contained in the sentence. And based on this, we define a metric called similarity, which is that given a document with the corresponding set P of intent phrases and the output summary O consisting of some number of sentences, we define a similarity score Sij, which is between the ith intent phrase from the set P or Pi and the jth sentence in the summary O or Oj. So the value of Sij is 1 if the intent phrase PI is contained in the output summary sentence OJ. Otherwise, it's zero. And based on that, we compute precision and recall, which can be used for F1 score computation. So in order to derive the intent-based F1 score, we define precision as the fraction of sentences in the summary that form a close pair with at least one intent phrase, and this gives the precision metric. And the fraction of intent phrases that form a close pair with at least one sentence from the summary gives us the recall. And the final F1 score is simply the harmonic mean of the precision score and the recall score. We have further mathematically described Sij, and then based on that, we have described precision P, recall R, and the F1 score. In addition to the task of extractive summarization, we also validate our metrics, that is precision, recall, and F1 score on document classification task as well. So now we will look at the experimentations which we did, so, which kind of validate our proposed evaluation method. So we use four types of summarization techniques that is based on graphical model, let sum, legal long formal, encoder decoder, and BERT. And we perform three types of tasks. Firstly, document classification, then intent classification, and then we report the automated metrics and compare it with our intent method. So for the task of document classification, we observe that boosting algorithms such as AdaBoost and domain pre-trained transformer models like legal part outperforms all the other models in terms of accuracy and macro reference score in both the Indian dataset as well as the Australian dataset. And for the task of intent classification, we train joint BERT and its variants to validate our proposed valuation method. So for all of these, we report automated metrics such as blue, meteor, rouge, L, sentence plus word mover similarity, and word score, along with our proposed metric for the task of extractive summarization. And some conclusions we observed are as follows. So graphical model tends to perform the best for lexical metrics such as blue, rouge, L, and meteor. The BERT extractive summarizer gives the best BERT score, which we kind of have an intuition for. The legal LED performs better on Indian dataset as compared to the Australian dataset. And in the case of Indian dataset, the LETSUM performs the best as per intent metric and S plus W MS score. While in case of Australian dataset, all the models perform almost equally well with respect to these metrics. And we also carry out our human evaluation to validate our proposed evaluation metric. The details can be obtained in our paper. So to summarize the results, we can see this figure 2. So for the different scores like blue, meteor, rouge, L, word score, sentence plus word move or similarity, and our defined intent metric. And for both the Indian dataset and Australian dataset, we see that for Indian dataset, the relevance is the highest for our intent metric, and the human score is also highest for our metric in the Indian dataset. Whereas for Australian dataset, the blue has the highest relevance and human score. Meteor has also the same human score as blue, and our model is also in a similar range as compared to the blue and meteor scores. But in terms of the Indian dataset, our defined metrics performs way better than the other predefined metrics. So the below figure is the image of our demonstration website, which is live right now. So if we look at a demonstration website, we can upload a TXT file which we would like to summarize, and the demonstration performs three different tasks. First, it can summarize the document using the four different models as mentioned earlier. Then the extraction of intent from the uploaded documents using joint BERT, and then the evaluation of summary generated by these above models. So with this, I would like to conclude our presentation of our paper. Thank you very much for giving me an opportunity to present our paper to you all. Thank you and have an excellent rest of the day.